Hello viewers and my dear students. We'll start with session 2 on projection of points. See here, I have just now told you the concept of right profile plane. As you know here, this is the VP, this is VP, this is HP and this is RPP. That means intersection of VP and HP is XY line and intersection of VP and RPP is X1 Y1 line. That is what I have written. XY line VP HP. X1 Y1 line is intersection of VP and RPP. Okay. And also I have told you the distance above HP is projected on VP. The distance in front of VP is projected on HP. Okay. Distance in front of VP is parallel to HP. In that way it projected on HP. The distance above HP is parallel to VP. In that way it is projected on VP. Okay. Now, as you see here, it is the distance from right profile plane. Okay. This 50 is parallel to this 50. Okay. This distance is 50 parallel to this. That means, since this is X1 Y1 line, from X1 Y1 line, this has to be 50. That means front view should be 50 distance. That means what you do, first you draw XY, then X1 Y1, then that is, since RPP is given, VP, HP, RPP you draw. Then from X1, Y1, first you draw 50. This is the distance from RPP. Okay, this is the distance from RPP. Once you draw that is 50, at this point you draw a line. 60 mm you take, 40 mm you take, and make a dot here clearly for front view. Where you make a dot here clearly here for top view. Make a dot here clearly for side view. As I said, this as soon as you look at this problem, you know very well. It is problem is point P 60 mm above HP, 40 mm in front of VP, 50 mm from RPP. Okay. The side view is P double dash. To get the side view, what I'll do is, from top view, I'll take a projector here and go this way and take a projector from front view. The intersection will give P double dash. But actually, you should know this. When P double dash is written, this distance is 40. That is from the intersection of VP and RPP. That means this distance is 40 means this, from intersection, this has to be 40. That has to be 40 here. And the distance is of P double dash, this distance should be above HP. That is 60 only. That is why 60 means this is 60, this is 40, that is in front of VP will be this distance. That is why what I'll do is, this distance in front of VP should be transferred here. In order to transfer that, we don't bother too much. We directly draw an XY line at 45 degree line for 45 degrees. Okay. Once you draw at 45 degree line, once you draw 45 degree, if you take this, then it creates an imaginary square in this way, no? This is 40 means automatically this will be 40. That means automatically this will be 40 and P double dash will be at this point, which is actually the distance in front of VP from X1 Y1 line. Okay. This 40 is this 40. Okay. Anyway, now you see here, section 2, same thing. See here, this is front view on VP, top view on HP, and X1 Y1 RPP. Okay, RPP are written. This is 60 mm above HP, 40 mm in front of VP, 50 mm from RPP, and P double dash, as you know here, whatever is this distance should be here, P double dash. Okay, you take a projector from here and cut 40 here, you get P double dash. Otherwise also, as I just now said, okay, draw on 45 degree line, okay, 45 degree line, meet this and go, automatically, even without your knowledge, automatically whatever is this distance, it will get transferred here to get the P double dash. Please observe, I have been telling you in the previous section itself, I told you, this is always in first angle projection, object comes first and then the plane. Object first comes and then the plane. Object comes first and then the plane. That is why in the front view, first you are meeting the object and then you are drawing the front view. Okay. In the top view also, first you are meeting the object and then drawing the top view. That is P. In the same way, On RPP, you are looking from left direction to get P double dash. That means it's the left view which you are seeing it on right profile plane. Please remember, for first angle on RPP, you are seeing the left view on RPP, because for one condition that you have to meet the object first and then the plane, as per the principle of first angle projection. Okay, it is always object first and then the plane, object first and then the plane, object first and then the plane, in that way. Okay, when you're looking from here, you should first meet the object first and then the plane. That is why left view, you get it on right profile plane. Okay, now the same thing, XY, X1, Y1, 60 above HP, 40 in front of VP, 50 mm from RPP, P double dash you get. Otherwise also draw 45-degree line, you get this left view. It's a simple problem to start with. Introduction of RPP I have done, and never forget, front view is on VP, top view is on HP, and on RPP you are getting the left view, okay. Now concept of left profile plane. You see a left profile plane I have drawn. This is HP is here. This is HP. This is VP. Okay, VP I have drawn. This is left profile plane. Now, observer position. You see here, observer position. If you do from the observer position this way, I am looking perpendicular to VP, no, to get the front view. Perpendicular to HP to get the top view. You are meeting the object first and then the plane. As a result, in order to get a view on left profile plane, you have to view from this position, because you have to meet the object first and then the plane. As a result, when you are looking from here, that P double dash, you get it here. Is it okay? P double dash, you get it here. That means it is, when you are looking from here for front view, okay, this will be the right view on left profile plane. Okay, be careful in first angle projection. Since you are meeting the object first and then the plane, you are looking from here compulsorily to get the, that is, right view on left profile plane. Okay, now it is same problem. I've introduced only one small change here. The change is only instead of RPP, I have got LPP. See here, VP, I have gone HP, and this is LPP. You open the plane in this way, so that X1, Y1 is the intersection of VP and LPP. Okay. Then, in the same way you do, if you do above HP parallel to VP, correct? No? Above HP parallel to VP, you get it here, P dash. Okay, P dash will be this. If this is 60 mm above HP, this 60 and this 60 parallel to XY line. From XY line above this, that is above XY line, you draw 60. How much is in front of VP? 40 mm in front of VP. 40 mm in front of VP is parallel to HP. That is why it is seen on top view. Okay, this is seen on top view. This is 40. And I have clearly given from LPP it is 50 mm. That is LPP. This, since this is 50, this will also be 50. In that way, you take 50 here, P dash P, and to get the side view, blindly you dash against the 45-degree line, what I have told you in the last session. That is, you blindly dash against this 45-degree line and go here, project it here, and you are getting P double dash. Okay. P double dash, as you know here, P double dash, if you see here, it is actually, this distance is 40, correct? No? This is 40 means, this is 40. 40 mm is the distance in front of VP. The distance in front of VP is actually projected here. Okay, that means this should be the distance in front of VP. This distance and this distance have to be same throughout. Whatever is this distance of P and this distance from X1, Y1 line, this distance and this distance have to be same. That is why I draw 45-degree line, so that it becomes a square. Once this is 40, this is also 40. Since it is 45, this will also be 40. Automatically, this distance will be 40 only. In that way, I have introduced the concept of this left profile plane also. Please observe here afterwards, the distance above HP is parallel to VP and projected on VP. Okay, distance above HP is parallel to VP and projected on VP. Distance in front of VP, like this. Okay, distance in front of VP is parallel to HP and will be projected on HP. Okay, you see a distance above HP parallel to VP. Distance in front of VP is parallel to HP and projected on that. And the distance, this distance of 50, if this is the intersection of VP and LPP, this distance is 50. That's what I've taken this distance. That's why you take 50 and then draw 60 and 40 and all that. Take the projectors in this way to get the side view. This is another simple problem where I've introduced LPP. On LPP, you should get right view. Okay. On RPP, you should get the left view of the object. Please remember in first angle, see here, since this you are looking from here for front view direction is this, right view you are getting it on left profile plane. Okay. If the right profile plane is here, left view you get it on right profile plane. This you should remember. Okay. Now you see here, this is, I have just opened the planes. Okay. VP, HP, LPP, XY, X1, Y1. I open the planes. Okay. So that it becomes a common plane. VP, HP, LPP. This, as soon as you look at that, 60 above HP, 40 in front of VP, 50 from LPP. In that way, whatever is this distance has to be transferred here to get the side view of the object. Three views of the point are written: P top view, P dash front view, P double dash the side view, which in fact is the right view here. Now, instead of showing the plane boundary and all that, okay, it need not be shown here afterwards. You blindly write on XY line, X1, Y1 line. Okay. Once you draw VP, entire thing is infinite plane here is VP. Infinite here, to accommodate any object, it will be HP, that is the top view. That is why, don't draw the boundary of the planes here afterwards. Just draw XY, X1, Y1. Take a distance of 50. From here, draw a line. This will be at a distance of 60, you get P dash. At a distance of 40, you get P. And then take a projector here. Take a projector here and get this P double dash, you get it. In that way, P dash, P and P double dash, that is the right view, front view and top view are obtained this way. I have introduced both the concepts of HP, that is RPP and LPP in these basic problems. Now you see here, now we'll start with the actual problem itself. A point is 40 mm above HP and 30 mm in front of VP and 50 mm from RPP. Okay. 40 mm above HP and 30 mm in front of VP is here. 40 mm, draw XY, X1, Y1, draw XY. Okay. 40 mm above HP, 30 mm in front of VP. Because anything you should know here, this is 40 mm above HP. Above HP should be projected on VP. Above HP is parallel to VP. That's why it should be projected on VP. 30 mm in front of VP. Okay. In front of VP is parallel to HP. Okay. In that way, draw XY, VP, HP you call it. 40 mm above HP is parallel to VP. That's why you project here. 30 mm in front of VP, you take 30 mm, you get top view. And it is 50 mm from RPP. VP and 50 mm you draw X1, Y1. Okay. This is XY. In order to get the side view of the object, what you do is, take the projectors here, take the projectors here. Actually, P double dash should be on this projector and this distance should be whatever is the distance in front of VP. Instead of doing that, I'll do 45-degree line so that without your knowledge, you are completing this. Okay. Once you do this and if you go here, you are getting P double dash automatically. That means this, whatever is this distance is actually getting transferred here. That means they'll ask you what exactly the use of 45-degree line means. This 45-degree line will help you to transfer the distance in front of VP to this distance, that is from X1, Y1 line. Okay. Now, the problem here is clear. As soon as you look at the problem, you should tell me. Okay. It is, problem is point P, which is 40 mm above HP, 30 mm in front of VP, and 50 mm from RPP. Okay. They'll ask you draw the three views of the point. You draw P dash, P and P double dash. And compulsorily, since RPP, you are looking in the left direction and you compulsorily write it as the left view. On RPP, you should always write the left view. On LPP, you should always write the right view. Okay. This is problem 15 from VTU manual. Okay. Now, we come to the end of session 2 on projection of points. We'll continue in session 3. Thank you, friends. Thank you.